Hello everybody, I am Mas. I go by Raining Coffee on Twitter. I do research at a fund out of Amsterdam called Maven 11. I primarily look at interoperability, CK, MEV, and things of that nature. And one of the things we're big fans of are IPC. We're big IPC fans. And one of the things that we care a lot about is bringing IPC beyond where it is now, which is primarily just the Cosmos ecosystem. So what this is looking at is why the hell do we even need IPC? And why don't all chains have IPC? And why is it important to have standardization within IPC that is being brought beyond the ecosystem it's currently in? So this is sort of a continuation of some of the stuff that we have done previously. We had a long article on the security and trust assumptions that we have in blockchain bridges. And what we essentially came down to was that security and trust assumptions matter. It's pretty important to have strong security and strong trust assumptions when you're bridging. And that generally you don't want to trust any smart contracts. You want to trust light clients. So in a perfect world, no bridges are being handled through smart contracts, but just through light clients and consensus verification. We've also looked beyond IPC previously, primarily with bringing IPC to Ethereum, but also other ecosystems through zero-knowledge proofs and what we call zero-knowledge light client verification. This is both with recursion and aggregation, which can also help bring down costs, because some of you might be aware that verifying tender mint block headers is pretty damn expensive. And I think most chains at this point actually subsidize this cost, and this just natively between Cosmos chains, which is obviously not ideal. And there's a lot of other teams that are working on this as well, not just Polymer, but plenty of others as well. And there's even hybrids of this that could be quite interesting to look at as well. The reason that we like appchains to begin with is because of the idea of warehousing block space. You get your own block space, you can define your own sequencing rules. You want sequencing rules for DEX or AMM, you can do that. Or if you have a specific purpose that's completely different, you can do that as well. But there are big problems still, and that is the fact that most chains beyond Cosmos don't have native interoperability. They don't have enshrined transport layers, and they are trusting third parties, state or middle chains, or smart contracts, which is not ideal. But still, despite all of this, the UX is still pretty bad. If you're a native and often user of Cosmos chains, it's not exactly ideal. Now, what we've seen happening over the last couple of months and years is this campaign explosion of Cosmos chains. This didn't used to look this way, but this is from a few days ago. We have a ton of chains, north of like 70 that have IPC enabled. Most of them, if not all, built with Cosmos DK and Tender Mint. But in our opinion, this is just the beginning. I think we're going to go beyond this with IPC. And we are seeing this happen already now. So we have a ton of different products that are working on bringing IPC beyond the ecosystem with various degrees of standardization. I'm not going to name names, but not all of them adhere completely to the IPC specifications. We also have people like Polymer that are trying to bring sort of a native transport layer built on IPC to enable channels that are specific to IPC. And then we have sort of the first part of what we call native cross-domain applications. These are products like Catalyst, Squid, Sommelier, Ume, that are natively cross-chain and that you can interact with on different chains and do a lot of very cool stuff as well. Now, if you're not completely aware of how bridging works, I'll give like a quick rundown. And this is not just IPC, it's other chains as well, but 4 things that are quite important is that you always have some monitoring. So you need to monitor that the state of the chain you're connected to is actually correct. Usually we do this with light clients in IPC. It could also be validators, like an XLR that run full nodes on all the connected chains. Or it could be an oracle, like with Layer 0, for example. Then we have relayers. They sit in the middle. It's in the name. They relay a message from one chain to another. And then we have some consensus somewhere. This could be natively on chains, like we have with IPC. Or it could be with XLR, where you have a state middle chain that is sort of off-chain from the 2 chains connected that will sign off on something being true. And they obviously need to run full nodes for this. And then we have signatures. So this is a way, how IPC works is that you get some signatures from the validators. You pass that message on, and you verify that signature as well. You can also do this with CKPs. So you can verify the signatures of a specific chain, and that some state is true, and you can then post that as a zero-knowledge proof. What is the validity proof? There's no zero-knowledge in that setup. Now with IPC, the way it works is very simple. Each chain wants a light client on the other, and you have a relay in the middle that relays a message. Now, what's important to have is this IPC module that can take in these messages and can verify them correctly. And it's also important to have a handshake. So this is often something we see on governance forums. So if you see a new chain launching, there'll be a governance proposal that says, let's open an IPC connection or channel to this specific chain. And that's important to have so that two validate sets agree on a specific light client being the correct one. Now, by verifying these two chains' state, we can essentially be pretty convinced that you have finality on both chains. So this is what we do with the light client. So the light client from chain A verifies the state of chain B and vice versa. And by doing so, we can have pretty high conviction if we trust the full nodes that we have finality on both chains. And all they do is actually quite simple. So the light clients essentially go and look at the block headers. So this is a state root at the top of a Merkle tree that has all the information of what's in the Merkle tree. And then you get state from an honest, trusted node. Obviously, if all the full nodes in the system are dishonest, then light clients are not very useful. You need some honest node to sort of be trustworthy to give you the correct state. And this is quite important, because if you don't have that, you're in a lot of trouble. This is very expensive, as I mentioned. If you want to verify this on customers' chains right now, it gets pretty expensive. So it gets subsidized for the most part. Otherwise, us sending IPC transactions would be a lot more expensive than it is now. If you want to verify this on a chain that has congested or extremely expensive block space, like Ethereum, for example, it gets even more expensive, which is not ideal. Now, why don't we just get IPC out of the box? Well, there's quite a few reasons. So we have quite a lot of dependencies on IPC. One of them is a module system. So this is what we have with customers chains, where we have automation, bank modules, IPC modules, and so on. We also need some introspection, so we can see what the state of consensus was. Sometimes that happens with a full node, like with XLR running full nodes on Ethereum and other chains as well. But we need this for light clients, and IPC relies on light clients. And then we need to support timeouts. So I think Jim touched a bit upon this earlier, but we need timeouts, so if a message doesn't get passed, we can time out the message so the message doesn't get actually passed and thrown over, and that we don't get weird scams. So we need some sort of time limit and some sort of concept of time as well. And then we need a port system, and this is for IPC to interact with other modules. So if I'm using a Interchain account or Interchain query, I need to be able to interact with the different modules. Could be an account module that has all the list of who owns what on each chain. So that's quite important. And we need a rollback system so that we can essentially roll back and revert state changes in case of some kind of fraud. And then we need data availability. This is quite important. This could be from Celestia, it could be from your own chain if you're a monolithic chain. But we need some conviction that the data of a specific set of transactions are actually valid and available. And then you'll also want deterministic consensus. So like Ethereum L1 doesn't really give very good deterministic properties. It does it to some extent, but actual finality on Ethereum usually between 12 to 15 minutes, depending on the active validator set. Now, one thing we can do is use validity proof. So you might know this as CK proofs, and we can essentially encode the logic of a light client into a circuit and use that to do very efficient verification of batches of transactions or batches of block headers. And then by using those previous block headers we have verified, we can sort of construct a chain on-chain as well. And this is also a good way to get trust minimized verification of something, because you can obviously verify the computation has been done correctly. And if we do recursive proofs or aggregated proofs, this is what we see over here, we can actually take a ton of different block headers. So let's say we have 20 blocks. We can verify all the block headers together for a single proof, and then we can post that on-chain. And this means we can have a lot of transactions within a single proof, so we get a high density, but with the same actual verification cost at the end of it. Now, what might have become clear over the last couple of months and years is that non-native bridging, that's not a part of the protocol, is super, super dangerous. So we have seen by far the highest amount of exploits with relation to bridges, which is also why applications that are building stuff with bridges or question mentioning protocols is quite dangerous, and you need to really care about trust assumptions and security. So if we are going out of protocol, like with most bridges beyond IPC, there's third-party risks. You're trusting third parties, you're taking multi-sig risks, you're taking smart contract risks. And there's no standardization between messaging. So if you're an application and you want to interact with some application using a different standardization, you might not be able to do that, which can also be quite problematic. But by using a sort of native bridging solution, we can also put trust in the social consensus and the signatures of that specific chain that we're connected to. Now, there's still some issues here that we need to solve. One of these is fungibility, and we'll get into that in a little bit. And even chains that share same DA layer, like Ethereum, rollups on Ethereum, or rollups from Celestia, even bridging between this gets quite difficult because we have challenge periods with optimistic rollups, we have proving times for validity proofs, and so on. So there are still problems with speed and latency that forces people to go to third-party bridges, even if there was a native bridge involved as well. Now, this common ground with IPC also brings forward a lot of interoperability, which is very, very cool. We get interchain accounts, interchain query, which is very important, specifically for the proliferation of staking that we might see coming out soon with LSM. Interchain queries and interchain accounts are a big part of actually getting cross-domain staking, which is going to be very cool to see. And we essentially get these transactions or messages that go from being for just a specific chain to being agnostic between a ton of different chains at the same time, which is very nice. Now, one of the things I talked about before was the issue of fungibility. So chains and customers, you can go from chain A to chain B to chain C, but if I have the same token from the same chain, I go chain A, D, E, and over here, then those tokens cannot be used in the same liquidity pools. So they become non-fungible tokens, which is a big problem if you're going through like two different chains going to osmosis. I can't interact with a chain with one that I've gone from, say, XLR, Neutron, osmosis. If I go from XLR, Cosmos Hub, osmosis, those can't be used together. So what we want here is path unwinding, which is essentially always sending the token or message back to the source chain of that specific token and then back to the destination. So the last chain it touches before the newest destination was always the source chain. So it'll always be fungible with all other tokens as well. And there's also a lot of other chains outside the Cosmic ecosystem that don't have modules. And that can also be a problem as well. Verification cost is still very, very high. And we don't have relay incentivization, which means running a V-layer could mean you're running at a loss. And most relayers right now are just validators that are running this so they can actually move tokens and other things around. But it's not incentivized to actually losing money in a lot of cases doing this. But what is very cool is we're building these public goods together that are expanding the abilities of IPC already. One of the things that one of the teams within Cosmos are building, I think is StrainLove are building packet-forward middleware. So this is essentially a module within IPC that will allow tokens to go back to the source chain, as we talked about with path unwinding, and then to the destination chain at the end of it. So we are getting better UX. We are sort of slowly getting there, but we're still sort of missing applications building on top of this. I know Catalyst and others are starting to do this to some extent, which should be quite cool. Now, we talked a bit about relayers before, and IPC relayers just passes the message across, which is quite nice. We have different types of connections as well. So a connection is just one chain has connected to the other chain, and you have different channels that are serviced by different relayers. And within that, you can have unordered and ordered channels. If it's unordered, you just check if a message has been achieved or not. So it's sort of first come, first serve. If it's ordered, you sort of get an order of what needs to be received by the IPC module. So there are different sort of ways of MEV can come into this, especially if you go with an unordered channel. You can get a fee market, and you can sort of extract MEV as a relayer by requiring people to intend to pay tip more if you want to get included first in an IPC transaction. But what's very important with relay incentivization is the fact that we need sort of not just the first come and the fastest and the most sort of geographically centralized located relayer to do this. We need to sort of have maybe a subset of relayers for one specific channel and so on, because otherwise it will always revert to centralization, like a lot of stuff in crypto does quite often. So it can't just be the fastest always wins. Now we come to sort of the modular idea and what's happening a lot in Celestia and with Ethereum is this proliferation of rollups and app chains and app-specific rollups that are happening that are using oftentimes the same DA layer. But the big problem with using the same DA layer now and sort of splitting up the stack of what you're using, is that we still need to verify everything that's usually just part of one chain. So we have execution, we have consensus, settlement goes into this a bit, and we have data availability. So by splitting this up, we now require more light clients. So if I am an IPC double chain, I'm monolithic, let's call this osmosis, I need to be running not just a light client on the execution layer to verify execution has been done correctly, but I also need to run a light client on the DA layer to verify that data is actually available. So we get more light clients, more cost, highly likely, and you still need to verify that all these have been correct. So we can either run a light client, or we can also relay through a relayer the validated signatures from Celestia or Ethereum or Veil or EigenDA back to that specific chain that you're connected to. So we need 3 convictions. We need data availability, we need transaction ordering, and we need execution and settlement of those specific transactions. So we get a separation of transport, verification, execution, which is quite important to keep in mind if you're trying to bridge between a rollup that's using a DA layer or similar. Now, one thing that we can do is that we can use relayers to sort of aggregate all of these proofs together of DA and execution. So what we can do is that we can post proofs of execution and of the correct fork choice rule, the correct chain, onto the DA layer, use a relayer to sort of relay that back for bridging back to the specific rollups that are using that DA layer, and even outside of that specific ecosystem. So light clients are quite important, but we can also use light client proofs to verify these things and aggregate them together and verify them together as well. There's a very cool implementation of this by Sovereign Labs, which I recommend checking out if you're interested in seeing how aggregated proofs of state can be used for bridging as well. Now, one thing we can also do is use shared sequencing. So we talked about before, transaction ordering is important, and we need proof of correct transaction ordering, we need proof of execution and proof of DA. So one thing that we can do is use a shared sequencing layer that is building these mega blocks for specific rollups. So we could have 2 rollups, rollup 1 and rollup 2, and we can have a mega block being built by a shared sequencer that's building and ordering for both of them. Now, one thing that becomes a problem is that each of these 2 nodes still need to verify that the other rollup actually executed those specific conditional transactions. This can be done via light client. So again, with IPC, you want to light client the other, and the other one wants to light client the other. And these conditional transactions are basically just transactions that say, okay, I want to go to this specific rollup. We need to make sure that that rollup has executed the exact same transactions. So it's primarily sort of limited to cross-domain transactions and messaging as well. What does become hard and slightly more expensive is that both of the rollups need to execute this exact same transactions, with adds to execution costs, and it also makes atomicity become a problem because we still need to validate that transaction was actually executed, either via zero knowledge proof or via a light client as well. And this depends a lot on block times within this specific 2 rollups as well. But it's a very cool way to sort of get very easy interoperability without needing to running too many light clients. Now, what's very important and what's sort of the end goal of this talk is that I want to make sure that people understand that standardization is super important. So we have a lot of developers in the IPC ecosystem that are building applications for various different chains, all wanting to use IPC specifications. And what they have right now is that they need to write logics for various different messaging and transport layers. So they need one for IPC, one for XLR, one for Hyperlane, one for Wormhole, as Larry puts here. And essentially what we want standardization, because IPC is no longer just limited to the Cosmos ecosystem, it's going beyond this. And when we do this, we need to make sure we have standardization, because standardization drives common innovation, and oftentimes the group will often outweigh what the few can do, and it also just increases interoperability and composability between chains that we're using. And this sort of also plays into aggregation theories that we want a singular UX with a singular interoperability standard. That means we can bridge and use all different chains within the same UX within specific applications. And IPC sort of enables this. And I think it's very important to make sure that people understand that having enshrined interoperability and protocol into the protocol is super important, because it enables native interoperability without trusting smart contracts and without trusting the trusted third parties. You prefer just want to trust the 2 chains that are actually involved in a cross-chain transaction. And that was it for me. Thank you. You can find me at 0x Raining Coffee on Twitter if you want to.